Okay, dear student, let's see what is there in this question. Two parallel conducting plates, they are separated by a distance of 5 centimeter. The variation of electric potential with the distance between the plate is shown. So the variation of the electric potential is given with respect to the distance. With respect to the distance. What is the magnitude of electric field strength? Okay, so let me get the data booklet and see if the formula is given there or not. I am on the page number 12 of your data booklet. And yeah, okay, so the formula is given there but not properly. V, sorry, E is equal to V by D is the formula given for SL students, and for HL student E is equal to delta V by delta D is the formula which is given there with a negative sign. Yes, so the negative sign is also given there. So this formula is given in the higher level section. This is for the SL section, you can say. But what is the formula and the concept that we are going to use here? E is equal to negative of dV by dr. Now, you have done a bit of calculus in your maths AAHL, so you already know what I have written there. E is equal to negative dV by dr. I can say that the electric field intensity can be found by, or it is equal to, the negative of the slope of VR graph or VD graph. Okay, so this is the graph here, this is V here, and K is also written. Be very careful about the units and the multipliers. So this is SI unit and the multiplier is kilo. Here the unit is centimeter, so you got to convert it into meters. They have already played the game. IB always messes up with this thing. So be very careful. So the formula that we are going to use is this. So clearly you have to find the slope. So these formulas, yeah, this formula can be used here. Delta V by delta T, you can say that. So the slope of this will be the tangent theta. Tangent theta is 20 minus 0, y2 minus y1 divided by x2 minus x1, which is 5 minus 0. But let me think about the units now. So it will be 20k, and this is 5 centimeters, which has to be converted into meters by dividing it by 100. So this will be further divided by 100. So 100 will go into the numerator. So I can just write the same thing as this. So 1, 2, 3, 4, 5, 6. So it is 2 into 10 raised to power 6 divided by 5 is the tangent theta that you have. Now this is the slope, and we want to find the negative of the slope. Okay, so the slope here is already negative. The graph is going down. This is the negative slope already. This is negative slope already. So the answer will be negative 2 by 5. So you want to find the negative of the slope, which is negative. So negative and negative cancels it out. So it becomes positive. So electric field value will be 2 by 5 into 10 raised to power 6 Newton per Coulomb, which is the unit for this. And how can we write it? 20 divided by 5 into 10 raised to power 5. Forza. So it is 4 into 10 raised to power 5. D will be absolutely correct answer here. Couple of things here. So first of all, we must understand what formulas are given in the data booklet and what are not given in the data booklet. The formulas which are given in the data booklet, what are the formations of that, which might be usable or which might not be usable. For example, in this case, they have literally skipped the derivation part and they have created their own formula. By the way, if you would be using the HL formula, yes, you can achieve the results, but this becomes a bit more easy and understandable because it is negative of dV by dr, which is the slope of V and R curve. So if tomorrow there is not a linear variation, some other variation is given, you know that you have to find the slope of the tangent at that point. But anyways, so the slope is given as this. Now the slope is negative because the graph is going down. This slope is positive. This slope is negative. Okay, the students, those who get confused, for them. So this is negative. So the slope is already negative, and you got to have negative of the negative slope, which becomes positive, and that is why your E is directly given as this. Now I just found the options here by just doing a very small arithmetic calculation. This is how we do this question. Beware of these formulas. Okay, dear students, this is Professor Varun. Thanks for watching. All the best. Bye.